Hello everyone, today I will explain how we turn a logic gate design into an IC chip simulation. Looking at the first slide, we have three inputs, E, D, and S. Inputs D and S feed into an XOR gate. The input of that gate goes into an AND gate along with input E to produce our final output Y. This means Y will only turn on if E is active and the first gate is successful. On the second slide, we see how this looks using real microchips. We use a 7486 chip at the bottom for our XOR logic and a 7408 chip at the top of our AND logic. We connect inputs D and S to the bottom chip, take its output and wire it straight into the top chip along with the input E. Our final output Y comes out of the top chip. Simulating this circuit with first allows us to test all input combinations and verify our truth tables safely before building the physical circuit in the lab.
Now let's look at how we physically build and test our circles on the train kit. We followed a quick 4-step process. First, we set up the digital logic trainer kit for power and switching inputs. Second, we moved our IC chips safely across the center gap of the breadboard. Third, we wired the logical paths using jumper wires. We connect input E to the first chip and then routed its output into the second chip along with inputs D and C. Finally, we connected power and ground to both chips. We flipped the train switches to test every input combination, successfully confirming that our physical circuits works perfectly.
First, looking at the pin diagrams on the left, we always consult the datasheets before wiring. For both the 7408 AND chip and the 7486 XOR chip, pin 14 connects to VCC for 5V power, while pin 7 connects directly to ground. The remaining pins handle our specific gate inputs and outputs. And next, on the right slide, we see the physical power and ground connections on our trainer kit. We route the 5V VCC from the trainer to the breadboard's positive power rail and the ground to the negative rail. From there, short jumper wires distributes power across the board so both ICs can easily share the same supply. Checking these connections carefully is critical as reversing power and ground can instantly, permanently damage the chips.
Hello everyone, my name is Bala Simpara and I'm gonna present my part in our digital design final presentation. My part is truth table, understanding 0 and 1. So first we have the truth table showcasing all 8 possible inputs combination for E, D and S. Based on our Boolean equation, the output Y should only turn on or become 1 during 2 specific scenarios when the inputs are 1, 0, 1 or 1, 1, 0. For all other 6 combinations, the expected output is 0. Next, we have our the second slide. The second slide. We have our physical, as you can see. This is the lab results. We tested all 8 states sequentially on the digital logic trainer kit in the lab at school. And as you can see from the labeled hardware, our physical circuit yielded a high output only during the 1, 0, and 1, and 1, 1, 0 states, perfectly matching our theoretical truth table. This successful experiment confirms that our logic design works flawlessly in practice. So thanks for listening.